For about a century, we've been looking at the universe through Einstein's lens. We see this grand stage of space-time where matter tells space how to curve, and that curve tells matter how to move. But what if that's only half the picture? Today, we're going to dig into a really radical new idea, one that seriously challenges everything we think we know about reality itself.
All right, let's just jump right in with this one huge question. What if time isn't just some passive thing that we're all moving through, like a boat on a river? What if time is the river? What if it's the active, creative force that's actually generating gravity, shaping entire galaxies, and even driving the expansion of the universe?
And that, right there, is the huge paradigm shift at the heart of a new theory called the vacuum cascade model, or VCM for short. It's asking us to completely rethink time, not as a coordinate on a map, but as the primary cause of, well, everything. So check this out. This is a great way to picture the difference. On the left, you've got the standard view we all learned. Time is just a river we're floating down. But on the right, the VCM view, it says time is the whole water cycle. It's the force that's carving the riverbed, creating the currents, and basically sustaining the entire system. A massive difference. And this quote from the model's creator, Jacek Bienkowski, just nails it. The passage of time itself is both the cause and the consequence of existence. It's this perfect feedback loop. Things exist because time is passing, and time passes because things are existing. It's a universe that is constantly actively creating itself, every single moment. Okay, so how does this whole thing actually work? Let's get into the mechanics of the vacuum cascade model. It's a really beautiful and honestly, in many ways, a much simpler way of looking at the cosmos. All right, this right here, this is the absolute cornerstone of the entire theory. So forget warped space for a second. The VCM says that gravity is just a direct result of time flowing at different speeds. A massive object, like our sun, doesn't just bend space. It literally slows down the flow of time around it. And that difference, that temporal gradient between the slow time near the sun and the faster time further away, that is what we feel as gravity. So where Einstein saw heavy things warping the fabric of space, VCM sees them warping the flow of time. It's a huge shift in thinking. And this is where the cascade part of the name comes in. Just picture space constantly pushing forward through time. This movement, it's not smooth. It creates a kind of pressure on the vacuum of space itself, sort of like when you move your hand through water and you create all these little ripples and currents. This pressure makes the vacuum separate into layers of different densities. And that continuous, cascading process is what ends up forming everything we see. And now we get to the really good part, the big payoff. Because look, a new theory is only as good as the problems it can solve. And the VCM offers some surprisingly elegant solutions to some of the absolute biggest mysteries in physics today. And I mean, we are talking about the heavy hitters here. Problems like dark energy and dark matter, these are the things that stumped the absolute giants, Einstein, Hawking, Planck, Penrose, for decades. They forced us to invent all these mysterious, unseen things to make the math work. But what if the answer wasn't about adding new stuff, but just about looking at time in a new way? So, first up, dark energy. Right now, we see the universe's expansion is speeding up, and we're like, whoa, something's got to be pushing it. We call that push dark energy. But the VCM says you don't need to push at all. In the gigantic, empty voids of space, there's way less matter to slow time down. So, time just naturally flows faster out there, and from our perspective, that looks like an accelerating expansion. It's not some mysterious energy, it's just a natural feature of the system. And what about dark matter? Same deal. We see galaxies spinning so fast they should fly apart. So we say, okay, there must be some invisible dark matter holding them together with extra gravity. The VCM has another idea. Remember those dense layers of the vacuum we talked about? They can create a kind of resistance and inertial drag. It's like trying to run through water instead of air. That denser medium creates an effect that perfectly mimics the pull of extra mass, but you don't need to invent any new undiscovered particles to explain it. This brings us to what is, no joke, one of the biggest headaches in modern cosmology, the Hubble tension. To put it simply, our two best ways of measuring how fast the universe is expanding are giving us two different answers. And it's not a small difference either. So here's the problem. On one side, we look at the oldest light in the universe, the cosmic microwave background, and we calculate an expansion rate. On the other side, we look at exploding stars, supernovae, in our own cosmic backyard, and we calculate the expansion rate again. And the local number is about 9% faster. Physicists are really stuck. Is our physics wrong or are our measurements wrong? Well, the VCM proposes a third option. It's not about what's wrong, it's about where we are. See, it turns out that our galaxy, the Milky Way, is sitting inside a truly massive, relatively empty patch of space called the KBC void. But in VCM language, you wouldn't just call it a void, you'd call it a temporal basin.
And here is the big aha moment. Remember what we said? Less matter means time flows faster? Well, because we live inside this giant void, this temporal basin, time right here flows just a little bit faster than the cosmic average. So of course our local measurements look faster. We're basically measuring the universe with a slightly fast-ticking clock. The Hubble tension suddenly isn't a crisis. It's evidence that we live in a special place. But solving today's biggest puzzles, that's not even the whole story. This model goes even bigger. It rewrites the very first page of our cosmic storybook.
Look, we all know the story of the Big Bang, right? A single, infinitely dense point, then boom, the universe is born. Well, the vacuum cascade model kind of throws that story right out the window. It describes a universe that's a continuous, self-creating process. It didn't need a beginning, and it doesn't have an end. It's a system that is just perpetually becoming. So let's just imagine for a second that this theory is on the right track. What does that actually mean for us, for humanity's future? Well, this is where things get really wild, and science fiction starts to sound a little bit like a potential roadmap. Because if time isn't just an abstract idea, if it's a real, physical, malleable force that you can actually interact with, well, the next logical question is, can we learn to control it? Can we engineer it? This opens the door to technologies that sound totally impossible today, but they're grounded in the physics of the VCM. No, seriously, just think about what this would mean. We're talking about spaceships that don't need rockets. They'd create a little bubble of faster time in front of them and just fall forward. The ability to literally turn gravity on and off, tapping the vacuum of space for limitless clean energy, or maybe even stopping things from aging by stabilizing the flow of time around them. It's a total reimagining of what technology could even be.
Which kind of leaves you with this one final thought, doesn't it? For so long, we've looked up at the stars and said space is the final frontier. But maybe we've been looking in the wrong direction all along. If the vacuum cascade model is right, the greatest discoveries, the biggest transformations in human history, they might not come from traveling through space, but from finally learning to navigate and maybe even control the very fabric of time itself.